Welcome to this video on end behavior. By the end of this video, you should be able to describe the end behavior of a linear graph and identify the characteristics of linear graphs, including domain, range, x-intercept, y-intercept, rate of change, increasing and decreasing, and end behavior. All right, so end behavior is the last of our characteristics that we're going to talk about. End behavior tells you what is happening at both the x and y values on the left hand of the graph and the right hand of the graph. So generally speaking, we're looking for what happens as x is decreasing, meaning as the x values go to the left, what is happening to the y values? Are they increasing by going up or decreasing by going down? Okay, that's on the left hand side of the graph. As the x decrease, we're talking about on the left. As the x increases, we're talking about on the right side of the graph. And we're saying as the x's go that way, to the right, what is happening to the y values? Are they increasing going up or are they decreasing going down? So let's take a look at this and see how it's going to work. So here I have a table of values. And this says as x decreases. So let me look. The x's are decreasing this direction, going up. I'm noticing that the x's are getting smaller as I go up. So as the x decreases, now let me look at my y values. If I do go in the same direction with my y values, what are they doing? They are also decreasing. So as x decreases, y decreases. Okay, now let's look as x gets bigger. What are our y values doing? They are also getting bigger. So as x increases, y increases. It just so happened that they match decreases and decreases, increases and increases this time. It doesn't always match that way. It depends on the graph. All right, so this is a table of values. You look at the x and y separately. Let's look at our actual graph. So as x decreases, we're talking about the x values are decreasing on this side of the graph. Where's the y values going? They're going up. So that means the y values are increasing. Okay, as the x's go to the left, the y values are going up. How about on the other side? As the x's are going to the right, the y values are going to continue on that line going down, so they're decreasing on the right. Okay, so let's try and do a whole bunch of characteristics all together and see how we do. Okay, so domain. When we're in a table of values, we're not talking about a continuous function. We're talking about a discrete function. So we only want to list the values that are here. Okay, so our x values are -2, -1, 0, 1, and 2. And I just got those from here. Now my y values, here's my y values. Remember, you want them in smallest to largest order. So the smallest y value is -2. And then we have 0, 2, 4, and 6. So we have our domain and we have our range. Now the x-intercept, remember an x-intercept is you have the x value comma 0 and the y-intercept will be 0 comma whatever the y value is. So I'm looking for an x value with a 0 next to it for my my x-intercept. So I'm looking a value with a 0 next to it for y. This is my x-intercept. So my x-intercept is at 1, 0. Okay, the y-intercept is 0 with a y value beside it. So I have a 0 with a y value next to it. So my y-intercept is 0, 2. Rate of change is slope. So let's get our 2 points. We have -2, 6. Because I want, if x is -2, what's my y value? Okay. And then I have an x value of 0 that has a y value of 2. And we're going to use our formula, y minus y, so 2 minus 6 divided by x minus x, 0 minus -2. 2 minus 6 is going to be -4. 0 minus -2 becomes 0 plus 2 divided by 2. Negative 4 divided by 2 gives me a rate of change of negative 2. Okay, the slope is negative. That means the graph is going down. So I'm just going to kind of draw us a visual here. The graph is going down is what that says. So we're decreasing as we go left to right. All right, now the end behavior, as x decreases, that means as the x's go left, what are my y values doing? They're going up, so my y values are increasing. And we can look at our table over here and come up with the same thing. As my x values decrease, my x values decreasing, they have to be going this direction as they decrease. They're getting smaller as they go this way. What are the y values going that same direction? They keep getting bigger. So as x decreases, y increases. And then as x increases, so as the x get bigger, they're going down, my y values are getting smaller as they go down. So as x increases, y decreases. Okay, and if we look at a simulated graph, this is not the graph of these points. It's just to give you an idea. If it has a negative slope, it looks like that. On the right-hand side, where the x's are increasing, the graph is going down, so that's why the y values are decreasing. All right, one last example. Let's give this a try. So there are no points on the end of this. I'm going to say let's throw some arrows on the end of this. Okay, so domain. My graph never stops going left, and my graph never stops going right. That means I'm going to have all real numbers for my domain. It's never stopping left to right. Every single x value will have a corresponding y value on the graph. Okay, now my range, I never stop going down, and I never stop going up. So it's all real numbers again, because I don't have any exact numbers. Now, my x-intercept, the point at which the graph crosses the x-axis, that occurs right there, and the name of that point is 3, 0. Now, our y-intercept is where the graph crosses the y-axis, because there's our x-intercept. Here's our y-intercept. The name of this point for the y-intercept is going to be, we didn't go left or right at all, we just went straight up 6, so it's 0, 6. Now, our rate of change, negative 2 to 0. Okay, so where x is negative 2 is here, and I can't quite see the graph up there. So I don't actually know the value off the top of my head, but here's what I do know. I do know that the graph of a line is, or the slope of a line is constant. It never changes. So I'm going to look. If I go down 2 and right 1, I hit the next point on the graph. If I go down 2 and right 1, do you see this? I can count the slope, and it doesn't matter where I'm asking on a line, a slope is constant. So I'm going down 2 and right 1. So my slope is negative 2. So even though I couldn't see the point that they wanted me to use, knowing that the graph is constant, I can count the slope anywhere along that and still figure out what it is. Okay. As we're going from left to right, this graph is decreasing, meaning it's going down. Now let's look at our end behavior. As the x's decrease, so as the x's go to the left, the y values are going up, so the y values are increasing. And then on the right, as the x's go to the right, the y values are going down, so the y values are decreasing. All right, hopefully that was helpful for you. Let me know if you have any questions, and I'll see you in class.